Refinement. Albert Einstein once said, "The whole of science is nothing more than the refinement of everyday thinking." What if we take this principle of refinement from an organism perfected in nature and apply it to an architectural element that can be used as a sustainable design solution for human protection and comfort? After visiting the site of O'Dowd Hall on the Oakland University campus, opportunities to pursue sustainable design solutions for light control and ventilation were explored. The 40-year-old mirror glazed facade emits a powerful and heinous reflection that infringes on the surrounding microclimate. Rochester, Michigan has 180 days of sunshine and 120 days of precipitation in a given year. 9 hours of daylight are admitted in winter solstice, with average high temperatures of 33 degrees and lows of 21 degrees Fahrenheit. Highs of 79 and lows of 58 are present in summer solstice, with 16 hours of available daylight. The focus of our exploration was to develop ways to control the powerful glare, contain artificial light, incorporate ventilation, and provide new opportunities to use natural light efficiently within the interior environment. The shape-shifting cell properties of the tulip petals were further refined to the independent element of the single cell of an auxetic array and became the unit of our initial prototype study. The single-celled unit has the standalone capacity to direct its own expansion and contraction motions into a functional and protective manner for human benefit. The investigative isolation of the single unit employed the manufacturing process of laminating. Laminating of flexible and resilient materials created a series of base unit prototype. Various mediums of paper, mylar, fabric, and plastic were selected for frame rigidity and pressure points to regulate shape memory and for translucency and fluidity that could aid in light diffusion and minimize interior heat gain. The unit was further refined modularly to generate an advancement of 3 additional prototypes using the manufacturing processes of laminating, paper folding, and laser cutting into brick, patch, and infill applications for architecture. Each of the 3 exhibited distinctive shading strategies with variable transparencies when exposed to heat, giving possibilities for architectural element transformation. The brick prototype, or self-supporting unit, was explored modularly to regulate the exchange of heat and light. It consists of 2 mylar courses, each made up of 8 single cells and woven with nitinol wire for activation. The extruded unit expands and contracts freely with a non-restrictive frame, which lends itself to the stackability of the object within a system. Expansion and contraction of the unit permits airflow to penetrate within the space and provide cross-ventilation within the interior environment. The materiality of the unit allows direct sunlight to be absorbed rather than reflected onto the surrounding microclimate, while the internal surface of the unit allows diffuse light to be transmitted and reflected within interior spaces. As a system, the prototype has possibilities to reduce interior heat gain and exterior glare, maintain regulated airflow, and enhance natural light quality through visual space interaction. The patch prototype was explored as a glazing application that was suspended by 2 steel cables and allowed for fluid movement of the system to expand and contract in an accordion-type motion in response to heat. As the heat increased with the direct sunlight of the day, the bimetallic coils responded to expand and close the system to provide shading into the interior environment. Translucent materials were used, which filtered the available natural light into usable interior light without initiating excessive heat gain. When the heat of the day decreased, the coils retracted and the units drew back into the resting position to allow outdoor views and natural light to flow freely within the space. This system has possible design outcomes of lowered energy consumption and ambient light control. The infill prototype was arrayed on the exterior of a glazed curtain wall system. The infill morphologically progressed through modification of the structural form and materiality of the single-cell unit. By reducing the thickness of the interior structure, new flexibility and light-emitting properties emerged when in an open position. An extended flange was added to the matte-finished exterior face of each unit, creating a nesting effect of sun-shielding scales covering the exposed glazing. The scales responded to fluctuating temperature changes, regulating expansion and contraction motions that allowed a continuous adjustment of light flow, light diffusion, and heat deflection to be present within the space. During the evening hours, the system redirects artificial light and contains it within the structure. Future possibilities of lowered energy consumption and light pollution reduction are possible with this prototype. Each of the three prototypes of the brick, patch, and infill were further refined to serve as architectural design solutions that proficiently blend with the surrounding environment of Oakland University's O'Dowd Hall. They all were consistent in maintaining their functions to enable shading strategies for human protection and comfort, and have potential to consumption through their practical designs.